HCAR breakers are indeed required for all heating, ventilation, and air conditioning units. This requirement stems from the National Electrical Code, specifically Section 440.22e. This section addresses the use of circuit breakers in HVAC equipment that is protected by a single overcurrent device. The critical provision states that circuit breakers installed in such HVAC equipment must be of the HCAR type. Understanding the purpose and implications of this requirement is crucial for ensuring safe and compliant HVAC installations. An HCAR breaker, which stands for heating, air conditioning, and refrigeration breaker, is a type of circuit breaker specifically designed to handle the high inrush currents associated with HVAC equipment. When HVAC equipment starts, particularly compressors and motors, it draws a significantly larger amount of current than during normal operation. This surge of current, known as inrush current or locked rotor current, can be several times the normal running current of the equipment. Standard circuit breakers might trip unnecessarily due to this high inrush current, leading to nuisance tripping and disrupting the operation of the HVAC system. HCAR breakers are designed with a higher magnetic trip point, which allows them to tolerate these high inrush currents without tripping. This higher trip point is achieved through internal design modifications that provide a short time delay before the breaker trips, allowing the inrush current to subside before activating the overcurrent protection mechanism. The NEC mandates the use of HCAR breakers in HVAC applications to prevent these nuisance trips and ensure the reliable operation of the equipment. It's important to note that while HCAR breakers are designed to tolerate high inrush currents, they still provide overcurrent protection. If a sustained overload or a short circuit occurs, the HCAR breaker will trip to protect the equipment and the electrical system from damage. The specific requirements for HCAR breakers are outlined in NEC Article 440, which covers air conditioning and refrigerating equipment. Section 440.22e, as referenced, is the key provision that mandates their use. However, other sections within Article 440 provide additional guidance on the selection and application of overcurrent protection devices for HVAC equipment. Firstly, it is important to determine the minimum circuit ampacity. Secondly, the maximum overcurrent protection must be determined. To correctly apply this NEC requirement, several factors must be considered. One must ensure that the circuit breaker is properly sized for the HVAC equipment it is protecting. The breaker's ampere rating must be sufficient to handle the normal running current of the equipment, as well as the inrush current during startup. Consult the HVAC equipment's nameplate for the rated running current and locked rotor current to determine the appropriate breaker size. One must also verify that the circuit breaker is listed and labeled as an HCAR type. This marking will be clearly indicated on the breaker itself. Only breakers specifically identified as HCAR should be used in HVAC applications. A further consideration is the interrupting rating of the circuit breaker. The interrupting rating is the maximum fault current that the breaker can safely interrupt. Select a breaker with an interrupting rating sufficient to handle the available fault current at the installation location. Furthermore, the installation must comply with all other applicable NEC requirements, including those related to wiring methods, grounding, and overcurrent protection. Ensure that the wiring and other components in the circuit are properly sized for the load and protected against overcurrent. It is critical to understand the difference between HCAR breakers and standard circuit breakers. Standard circuit breakers are designed for general-purpose applications and may not be suitable for HVAC equipment due to their low magnetic trip points. Using a standard circuit breaker in an HVAC application can lead to nuisance tripping and potentially damage to the equipment. HCAR breakers, on the other hand, are specifically designed for the unique demands of HVAC equipment and provide a more reliable and safer solution. Firstly, standard breakers are not designed for high inrush. Secondly, using a standard breaker can cause damage. The NEC requirement for HCAR breakers is not simply a recommendation, it is a mandatory safety measure. Failure to comply with this requirement can result in electrical hazards, equipment damage, and code violations. Electrical inspectors will typically verify the presence of HCAR breakers during inspections of HVAC installations. Non-compliance can lead to rejection of the installation and require corrective action. In addition to the NEC, UL standards also play a role in the safety and performance of circuit breakers. UL 489 is the standard for molded case circuit breakers and circuit breaker enclosures. This standard specifies the testing and performance requirements for circuit breakers, including HCAR-type breakers. Circuit breakers that meet UL 489 are listed and labeled by UL, indicating that they have been tested and certified to meet the standards requirement. The UL listing mark provides assurance that the breaker has been evaluated for safety and performance. When selecting circuit breakers for HVAC applications, it is important to choose breakers that are both NEC compliant and UL listed. This ensures that the breakers meet the required safety and performance standards. Here's a more detailed breakdown of NEC section 440.22e and its implications. The phrase circuit breakers installed in HVAC equipment refers to circuit breakers that are physically located within the HVAC unit itself or in a separate enclosure that is directly associated with the HVAC unit. This could include circuit breakers in a disconnect switch located near the outdoor condenser unit or in a control panel within the air handler. The phrase protected by a single overcurrent device means that the HVAC equipment is protected by a single circuit breaker or set of fuses that provides overcurrent protection for the entire unit. This is in contrast to situations where multiple overcurrent devices are used to protect different components within the HVAC unit. The phrase shall be HCAR type is the key requirement that mandates the use of HCAR breakers in these applications. It is a clear and unambiguous statement that leaves no room for interpretation. The term HCAR type refers to circuit breakers that are specifically designed and labeled for use in heating, air conditioning, and refrigeration applications. These breakers have a higher magnetic trip point to accommodate the high inrush currents associated with HVAC equipment. It is also important to understand the role of the equipment manufacturer in specifying overcurrent protection requirements. HVAC equipment manufacturers typically specify the type and size of circuit breaker that should be used to protect their equipment. These specifications are usually found on the equipment's nameplate or in the installation instructions. Always follow the manufacturer's recommendations when selecting circuit breakers for HVAC equipment. In many cases, the manufacturer will specify that HCAR breakers must be used. Even if the manufacturer does not explicitly specify HCAR breakers, it is generally a good practice to use them in HVAC applications, especially if the equipment is protected by a single overcurrent device. Using HCAR breakers provides an extra margin of safety and helps to prevent nuisance tripping. Here are some practical examples of how this NEC requirement applies in real-world situations. An example is a residential central air conditioning system. A central air conditioning system typically consists of an outdoor condenser unit and an indoor air handler. The condenser unit contains a compressor and fan motor, which both draw high inrush currents during startup. The air handler contains a blower motor, which also draws inrush current. If the air conditioning system is protected by a single circuit breaker in the main electrical panel, that circuit breaker must be in HCAR type. Another example is a commercial rooftop HVAC unit. Commercial rooftop HVAC units are commonly used to provide heating and cooling for office buildings, retail stores, and other commercial spaces. These units typically contain multiple compressors and fan motors, all of which draw high inrush currents. If the rooftop unit is protected by a single circuit breaker, that breaker must be in HCAR type. Another example is a heat pump system. Heat pump systems are similar to air conditioning systems, but they can also provide heating in addition to cooling. Heat pump systems typically contain a compressor, fan motors, and reversing valve, all of which draw inrush currents. If the heat pump system is protected by a single circuit breaker, that breaker must be in HCAR type. A further example is a ductless mini-split system. Ductless mini-split systems are a type of air conditioning system that does not use ductwork. These systems typically consist of an outdoor condensing unit and one or more indoor air handlers. The condensing unit contains a compressor and fan motor, which both draw high inrush currents. The indoor air handlers contain blower motors, which also draw inrush current. If the mini-split system is protected by a single circuit breaker, that circuit breaker must be in HCAR type. There are also some exceptions and clarifications to the NEC requirement for HCAR breakers. While the NEC generally requires HCAR breakers for HVAC equipment protected by a single overcurrent device, there may be some exceptions or clarifications depending on the specific application and local interpretations of the code. For example, some jurisdictions may allow the use of standard circuit breakers if the HVAC equipment is specifically designed and tested to operate with standard breakers without nuisance tripping. However, it is important to consult with the local electrical inspector to determine the specific requirements in your area. It is also important to note that the NEC requirements for HCAR breakers are constantly evolving as technology advances and new types of HVAC equipment are developed. Stay up to date on the latest code changes to ensure that you are complying with the most current requirements. In summary, the NEC requirement for HCAR breakers is a critical safety measure that helps to prevent nuisance tripping and ensure the reliable operation of HVAC equipment. By understanding the purpose and implications of this requirement, you can ensure that your HVAC installations are safe, compliant, and efficient. Always consult with a qualified electrician to determine the appropriate type and size of circuit breaker for your specific HVAC application. Proper selection and installation of circuit breakers is essential for protecting your equipment and ensuring the safety of your electrical system. When selecting an HCAR breaker, several factors should be considered to ensure it meets the specific requirements of the HVAC unit. Firstly, the voltage rating of the breaker must match the voltage of the HVAC system. Secondly, the ampere rating of the breaker must be sufficient to handle the full load current of the HVAC unit, including the compressor, fan motors, and other components. Thirdly, the interrupting rating of the breaker must be high enough to safely interrupt any potential fault currents in the system. An understanding of the different types of HCAR breakers available is also needed. HCAR breakers are available in various sizes and configurations, including single-pole, double-pole, and three-pole breakers. The type of breaker required will depend on the specific wiring configuration of the HVAC unit. In addition to circuit breakers, fuses can also be used to provide overcurrent protection for HVAC equipment. Fuses offer a different type of protection compared to circuit breakers. Fuses are one-time devices that melt and interrupt the circuit when an overcurrent occurs. Circuit breakers, on the other hand, can be reset after tripping. The choice between fuses and circuit breakers depends on the specific application and preferences of the installer. However, it is important to ensure that the selected overcurrent protection device is properly sized and rated for the HVAC equipment. Another aspect of HCAR breaker application is coordination with other protective devices in the electrical system. Selective coordination ensures that only the overcurrent device closest to the fault trips, minimizing the impact on the rest of the system. This is particularly important in commercial and industrial facilities where downtime can be costly. Achieving selective coordination requires careful selection and setting of overcurrent devices throughout the electrical system. Furthermore, consider the environmental conditions in which the HCAR breaker will be installed. If the breaker is exposed to moisture, dust, or extreme temperatures, a suitable enclosure should be used to protect it from the elements. NEMA-rated enclosures are commonly used to provide environmental protection for electrical equipment. Regular inspection and maintenance of HCAR breakers are essential for ensuring their continued reliability. Breakers should be visually inspected for any signs of damage or deterioration. The breaker's trip mechanism should also be tested periodically to ensure it is functioning properly. Any faulty or damaged breakers should be replaced immediately. Knowledge of common problems associated with HCAR breakers is also useful. Nuisance tripping, as previously mentioned, is a common issue. This can be caused by undersized breakers, loose connections, or faulty equipment. Overheating of breakers is another potential problem. This can be caused by overloaded circuits, loose connections, or improper ventilation. Proper troubleshooting techniques can help identify and resolve these issues. The increasing use of variable frequency drives, or VFDs, in HVAC systems has introduced new considerations for overcurrent protection. VFD control the speed of motors, which can reduce energy consumption and improve system performance. However, VFD can also generate harmonic currents which can affect the performance of overcurrent devices. It is important to select HCAR breakers that are specifically designed for use with VFD. Moreover, the integration of smart grid technologies and building automation systems is also impacting the design and operation of HVAC systems. Smart grid technologies enable real-time monitoring and control of energy consumption. Building automation systems allow for centralized control of HVAC equipment. These technologies require sophisticated overcurrent protection schemes to ensure the safety and reliability of the electrical system. This requirement is not just a matter of compliance, but also a matter of safety and best practice. By adhering to these guidelines, electrical professionals can ensure the safe and reliable operation of HVAC systems, protecting both property and people. Remember to always consult the latest edition of the National Electrical Code and any applicable local codes for the most up-to-date requirements. Also, consult with qualified electrical engineers or inspectors for guidance on specific applications. The information provided here is intended for general educational purposes only and should not be considered a substitute for professional advice. Correctly identifying a faulty breaker is essential. If a breaker continues to trip frequently or exhibits signs of damage such as discoloration or melting, it should be replaced by a qualified technician. Do not attempt to repair a faulty breaker yourself, as this can be dangerous. Instead, contact a licensed electrician who can properly diagnose and repair the problem. Proper documentation and record keeping are also important aspects of electrical safety. Maintain accurate records of all electrical work performed, including the installation and maintenance of HCAR breakers. These records can be helpful for troubleshooting problems and ensuring compliance with regulations. Finally, remember that electrical safety is everyone's responsibility. By following safe work practices and adhering to applicable codes and standards, we can all help prevent electrical accidents and ensure a safe working environment. Continuous learning and professional development are essential for electrical professionals. Stay up to date on the latest technologies, codes, and standards by attending training courses, seminars, and conferences. By investing in your knowledge and skills, you can provide the best possible service to your customers and ensure the safety of the public. In conclusion, understanding and applying the NEC requirements for HCAR breakers in HVAC systems is a critical aspect of electrical safety. By following the guidelines outlined in this discussion, you can ensure that your HVAC installations are safe, compliant, and reliable. Always prioritize safety and consult with qualified professionals when necessary.